So it's obvious that all of you must be greatly interested in learning big data, and that's why you all are here. So it's going to be an amazing journey. You learning big data. It's very interesting, and it's also going to give you a good career opportunity after learning this course, because we are going to go through all the components which are required to uh, have your career in big data. We have these. We'll be covering the topics like HDFS, MapReduce, Yarn, Sqoop, Flume, Hive, Pig, Hbase, Oozie, Zookeeper, and a brief introduction of Spark. Also, throughout the course, we'll be having good number of quiz questions, assignments for each and every topic, and good amount of project work related to the technologies. Like supposing if I cover 2 topics, then after 2 topics I'll be giving you some projects, not that for the whole after the whole course. So kind of project learning with projects will be there in the course. Also I'll help you in preparing for interviews, interview preparation, interview questions I'll be providing you. And if you're interested, we separately will be having also we'll be including the certification, CCA for Cloudera is one of the distributions for Hadoop, and people go for this certification, and that really adds to your resume. So these days people are really asking for the Cloudera certified professionals. So here in this course we are also going to prepare for the certification, that is the CCA Hadoop and Spark developer certification, that also will be going through in the course. So this course is actually going to give you good hands-on experience as well if you do not have any prior experience also in IT. Also, it will add to your resume certification you can crack with the help of the course, and that will definitely add to your resume, help you in getting the job. And if you're already working and not looking for a job, but in your company also, these technologies which you're learning, you'll be able to implement them in your projects. So big data is the buzzword, and there's going to be huge requirement. There is already huge requirement. If you have uploaded your resume with big data as your technology is your expertise, then you see that you have a lot of job openings coming, a lot of job in your inboxes coming daily with big data, Hadoop and Spark, all these technologies. So, and it's also true that it's going to offer you a good salary. So that is also very lucrative. That's why people are looking for this. Yes. So you need to learn big data skills and you'll be the top paid in the market. That is for sure. So you must be hearing a lot about big data. Maybe you know also, but let's have a quick introduction on what is big data and what is Hadoop, and what are the big data roles you can have, or the job market, and what is going to be the future. If your current role is a test, if you're in testing, or if you are a developer, or if you're an admin, so how can learning big data give you a better future, and what type of job you'll be getting in the market related to big data. So today I'm going to have this introduction on the big data. So how many of you already know about big data? Any quickly on the chat box? How many already know? Yes, what is big data? We already know, or just we know just brief, or we don't know. Can you quickly ping in the chat box? Yeah, that's great, because so you have a little bit knowledge about what is big data. So I'm going through the basics, because I believe that not everybody must be knowing here. So yeah, I got a message that Sasikiran about. So we need to take up from the beginning, because many people won't be knowing about big data. So let's start. So how big data came into picture? So previously you had only calls and text messages with this type of phone. You remember this mobile phone, which you hardly see these days. So there you could do only calls or text messages. That was maximum you could do, or maybe click some picture maybe, but not really very good pictures you could click. So how big data came into picture? Now with the advent of this smartphone technologies, you have different apps you can use for music, sports, games, social media, and for chatting, and many various apps you're using these days. So you are generating actually huge amount of data. So because of these applications being used not only by you but various companies, most of the companies, almost all companies are using social media for their businesses like Twitter, LinkedIn, or Facebook. They're using for their marketing purpose social media. So they are actually generating huge amount of data. So what is big data? Uh, so I give you one example where uh, big data itself word means, okay, it's going to be extremely large amount of data, huge data. Okay, fine. There is going to be huge volume of data. So how is this data getting generated? Why means earlier was there not big data was not there? Yes, earlier now, like I give you one example. Supposing you are going to a shop market and you want to buy a toothpaste, and you buy toothpaste every 2 months. So that shop market tracks it predicts, okay, that next month you're going to come and buy a toothpaste. So it actually sees the patterns or the trends and what according to the human behavior, like how are you purchasing a particular product every month or every other 2 months. So it's going to see your patterns, it's going to analyze, and it might give you some discount based on that. Now the shop market knows that this particular person is really interested in these type of products, so it can make its customers happy by giving it more discount on the product, right? So it's actually the huge amount of data which is used to, so this huge amount of data it's gathering from the customers, how they're purchasing. It's then getting the patterns or trends, okay, what type of product they are purchasing, when they are purchasing, what they are interested in, and then they predict something useful out of it. So this is how companies are leveraging the benefit of big data. Okay. So big data is actually the extreme large amount of data, and that can be analyzed computationally. You need to analyze that huge amount of data that reveals some patterns or trends related to the human behavior, and then you predict something useful out of it. Okay, there is a prediction that's okay, this particular person is buying this product every month. So this big data is actually very useful. Companies are not say data was actually there earlier also, but with though their growth in business with social media and all these technologies coming up, companies are not actually throwing up this data, because this data they will analyze and use to have growth in their businesses. So they need to analyze the patterns and trends in their customers behavior. So they need to store this data. They just cannot throw away this data. So this big data is really useful for them. And the data is growing. So previously we were working, okay, we had till gigabytes of data, kilobytes, megabytes, gigabytes of data. But this range from this terabyte to yottabyte, this is considered, that is coming under the big data. Okay, so this range from 1 terabyte to 1 yottabyte, it's coming under big data. You know, this Facebook is generating around 300 petabytes of data, and a huge amount of data is being generated by Facebook and all these companies. So everything, so you cannot say gigabytes data is big data. The data that is lying from above terabytes, petabytes, exabytes, zettabytes, or yottabytes, till those ranges, these are considered the big data. So the data is growing and growing, because we are every minute we are sending 306 million emails, having 3.4 million likes and comments on Facebook. Maybe this is all based on some data collected. So we are uploading thousands of photographs on Facebook, sending thousands of tweets every time, and we are uploading 100 hours of videos on YouTube. So it's approximately, it's expected by 2020, the huge amount of data will be generated, that is 40 zettabytes of data. You can think of the huge amount of data that is 40 zettabytes will equal to. So currently we have around 2.3 zettabytes of data that has got generated. So data is the new oil. We need to find it, extract it, refine it, distribute it, and most importantly, monetize it. So data is the new currency, and companies are really leveraging the benefits of big data. It's an asset, and data is the new currency now. Okay. So this data is so important for companies that we need to extract it, refine it, and monetize it, because this is with the huge amount of data you have, if you do not, you need not throw it away. You cannot throw it away, because that's going to help you grow your businesses and finally monetize it. So is this big data really valuable? If you have gone through Amazon, then you must be knowing that if you search for some product, it will also give you some recommendation based on what you are searching for. Supposing you are searching for gaming mouse on Amazon, then it will give you some recommendation like this. Okay, customers who bought this item also bought this. So it is actually, when you log into Amazon, you will have your personalized experience based on your recommendation. Every person will have their own personalized page that makes customers really happy, right? So how is Amazon able to give you so many recommendations and these things? This is all because it's leveraging the benefits of big data. It's collecting the huge amount of data that people are searching and looking for, and then it collects and analyzes and gives you the result based on that. So this big data is really valuable. You cannot just throw it away. You need to store the data somewhere, and you need to analyze and grow, help the grow your business. So these days, you see, all companies, even a startup, they have to use this technology, because everybody is going to use social media, and it's going to generate huge amount of data, and they have to actually integrate this technology in their company. So everybody here in every company is going to require people who are proficient in this technology. Another example of recommendation is Google revamps Play Music with optional recommendation based on your location and activity. If you're walking into gym, it will recommend you workout music. If it's a sunset, then a sunset soundtrack appears according to the situation, according to your location and activity. It's going to recommend you the music. Another example is the location-based ads. So mobiles are ubiquitous. Mobiles are everywhere. So you need to give real-time based location ads using GPS. So companies these days, supposing you are located near Big Bazaar, and at that point of time you get a message from Big Bazaar that we are offering a discount on this product. So they will offer you discount on the product which you have been buying from Big Bazaar, right? And you are interested in, right? Or you have made some recent purchases. Accordingly, Big Bazaar will offer you discount. It won't offer a discount on a product. Suppose you're a man and it's going to offer you discount on some ladies product. So it knows what your gender is, what your profile is, what you have been interested in purchasing, and what your location is. So Big Bazaar has to store huge amount of data. It needs to store about your data, that what you have purchased recently, what you are interested in, what is your profile, what is your gender, what you will be more interested in, what is your current location, and all that. It needs to have the data saved and then analyze accordingly and give you some discount, right? It cannot give you any random discount that you won't like, right? So these location based ads, they're also using the we need to actually leverage the benefits of big data. So we need to analyze that huge amount of data. Okay. So these companies these days are also giving you real-time based location ads using GPS. They also require to leverage the benefits of big data. They need to store this huge amount of data and analyze it in an efficient manner to give you some discounts and give you some advertisement based discounts. Then Even these traveling companies like Yatra.com, ClearTrip, Make My Trip, they're also using, they're leveraging the benefits of big data, because again here people are going to search about hotels, and also result is based on what other customers have chosen on. So it doesn't give you huge list of the hotels. It will give you some specific list where the customers already have recommended or chosen from. So the result is that you do not have to go through a huge list. Supposing as a customer you go to this site Make My Trip and search for hotels, that give you 10,000s of list of that maybe. So you won't like that. You want, okay, some good hotels I want which really people liked and are really good. So it gives you personalized experience of that. So this all happens because it is collecting data from what other peoples are recommending, kind of analyzing and merging them. So almost all industries, I must say all industries are using big data, and they are transforming their business models, and they're improving their performance in many areas, be it retail, be it financial services, advertising and public relations, government sector, or any sector, healthcare, life sciences, manufacturing, all are using this big data. Then big data is a misnomer. Misnomer in it isn't just about volume. So it's not just that, it's the challenge. So one of the challenge of big data is volume. So we have got huge amount of data. So it's not just one of the challenges. Here we are going to discuss 4 V's of big data, which means the 4, you can think of this 4 challenges, okay, what we face with big data. So when we have got huge amount of data, obviously volume is a challenge. How to store that huge amount of data? It is going to cost you a lot when you want to store huge amount of data. So by 2020 we found from the database that 40 zettabytes of data we're going to generate, and there are going to be huge amount of data that's going to be generated. So this is one of the challenges, that is the volume. How to people were actually facing this challenge, like now data is growing so much, we cannot throw it away, we need to store it somewhere. So that is one of the challenges. Another challenge is variety. So earlier, like I told you, we just had text messages or those type of data only, but now with the social media we have the images, we have the videos, we have a lot of contents which is in the different forms of data. So variety means it's not going to be just structured data. Structured data means the form of, if you think of relational databases or Excels, where you store data in the form of rows and columns, that is going to, that you analyze, that easy to do that. But what about the different types of data? Now they are getting generated like tweets or the Facebook post. So how to analyze that type of data which is not in any structure, it doesn't have any structure? So that is also one of the challenges. Another challenge is the velocity. So velocity, for example, I give you like you're searching a product on Amazon, okay, gaming mouse only, and at that point of time you get a message, okay, there is going to be discount on this product called gaming mouse, and so how quickly you get that? Because they don't want to lose their customers. The moment you are searching for a product, they'll offer you discounts so that you do not go to any other site, any of their competitors to go and buy that product. So that is, they have to be very fast. Now if I am searching today and they give me a mail tomorrow, okay, we are giving you a discount, till then this is online, no, everything is online, so for fast I can go to some other site and buy that product. So they have to be very fast in giving me discount. They cannot wait for one day. So velocity, data at rate at which data is coming into the system, okay, that need to be analyzed very quickly. So that is also one of the challenges. Okay, so you need to analyze the streaming data that is coming in real time, like tweets are getting generated in real time. You see, tweets are generated quickly. So now supposing I want to capture the tweets and want to analyze them quickly. So I need to have something that it means this is a challenge, like getting the tweets and getting the tweets and then analyzing them, because I need to analyze tweets because I want to see how my customers are reacting to my products. And tweets, they are telling my product is like this. I want to see how my customer are customer behavior is relevant to my products, right? Then as the veracity, there is uncertainty of data. Maybe the data is coming from untrusted information. So all these are the challenges: volume, variety, velocity, and veracity. So there is going to be uncertainty of data, from which sources it's going to come, is the data quality poor. All those things need to be taken care and considered before you can do any analysis on the data, right? So what are the characteristics of big data? We just talked about volume. So how is this huge volume generated? That can be machine generated through sensors or personal health trackers. People are generating huge amount of data through social media, Facebook, Twitter, LinkedIn, and all these things. And then you have YouTube, where you're uploading the videos. Then organizations are also generating huge amount of data, which have their with the credit card information they need to save commercial transactions, then medical records in hospitals. So all these are generating huge amount of data, and that is definitely a challenge how to store them. And the velocity is another challenge, the rate at which data is coming into the system and rate at which it needs to be analyzed. That speed of processing should be faster than the new arrival of data. And variety, so there can be unstructured data or structured data. Structured means it has some definite patterns, it has some repeated patterns like relational database, Excel sheets and all. But unstructured data that doesn't have any predefined pattern, okay? So it can be tweets, Facebook posts, all these videos, images, they do not have any defined pattern, so they are considered unstructured type of data. Now we have seen the problem. Vino is saying I'm unable to hear you. Are others able to hear me? Vishal, Vikas. Now it's fine? Okay. Thanks for confirming. Okay. So now we know the problems, the challenges we have. We have the challenge of volume. We have challenge of variety, velocity. So what is the solution to this problem? Okay. Any questions till now? No questions? Yes. So the solution to the problem is okay. Now supposing you have one machine, okay, you are working here and you have 100 terabytes of hard disk, okay, and say some 1 terabyte of RAM. Okay, 100 terabytes of hard disk and you have say 1 terabytes of RAM. So now your data has started growing. Now supposing you have 200 terabytes of data, okay, you need to add 100 terabytes of hard disk more, right? What will be the solution? Supposing your data is growing, now you want to store 200 terabytes of data, so you'll add 100 terabytes of hard disk more to this machine. Now if you want to store 300, again you'll start adding to this machine. Now but the thing is, this is going to be really expensive and going to be really complex. If you are, this is going to increase the complexity, and also it's going to be costly if you are increasing the hard disk, if you're increasing the capacity of the machine every time your data is growing. So another approach is like if one person is not able to handle a problem, what you do? You divide the task among two people, right? Now, if two people are also, it means that if your task is huge and even two people are not able to handle the problem, so you divide the task among three people, right? Similarly, if three people are also not able to handle the task, you divide the task among four people. So that is the other approach that is called distributed approach. So here, if instead of adding 100 terabytes to this machine, you are going to have one more machine with 100 terabytes capacity. Again, the data is growing, then you'll add one more machine. Again, the data is growing, you'll add one more machine. Okay, so this is how you are going to scale out. Now, this is a good solution that you're going to distribute your data among these machines. But the problem is, like, this is looking like a team without a captain, or means you need to have something which needs to coordinate among these. Because what happens if hard disk crashes and one node fails? Okay, and how are they going to coordinate among each other? So you need to have a framework so that these can communicate among each other, and also it will be able to know, like, what will happen if the hard disk crashes here. It should be able to know, right? So the solution to this problem of distributed system is Hadoop. So Hadoop came as a framework to actually take care of the coordinating between these systems and take care of the failures that is going to be there. So you need to have a framework to coordinate among. So Hadoop came as a solution to this. So this is a distributed, you can think these are known as nodes in Hadoop world, and this is called a cluster of say 4 nodes. So this is a 4 node cluster, and these individual machines are called nodes, and the collection of nodes is called a cluster. So solution to the problem of big data, of having huge volume this is that you need to use some distributed systems. What does distributed system mean? That you need to use multiple machines for a single job. You need to have you can have as many machines as you want according to your requirement. If you have you want to store more data, you'll add one more machine. If you want to store more data, again you'll add more machine. So distributed system, they use multiple machines, but for the same task. Rather than adding the hard disk and more to increase, rather than increasing the capacity of the single machine, it's going to do the distribution. So what are the challenges of distributed system? There can be machine failure, or there will be high programming complexity, but the solution is Hadoop. Hadoop is a framework, and it is going to help in this distributed processing of large data sets and across these clusters of commodity computers using simple programming models. So the advantage is that now the cost will be cheap. Why? Because in Hadoop world, there will be, so this is Hadoop framework is specifically for distributed processing of data. So you can store the data in different nodes and also process them parallelly. Okay. So Hadoop is a framework that is going to allow you to do distributed processing of huge data sets or cluster of commodity computers. Another important point is the commodity computers, means one in a cluster, one node will be the master node, other nodes will be slave nodes. So the slave nodes, they will be the cheap commodity hardware. So they won't be expensive. They will be the cheap commodity hardwares. Okay. And they'll be using simple programming models. Only one node will be a high-end machine, while others will be the cheap commodity hardware. So that saves on the cost. And because they're cheap commodity hardware, there is a possibility of their failure also. Okay. So there is some question arising in you, how it's going to store the data, and what if one node fails? So how is it going to do all that? Any questions coming in your mind? No? So Hadoop will take care of loss of data on one machine, and it will take care how to store the data on different machines and how to process them parallelly also. So Hadoop is key characteristics, we can say scalable. You can add as many machines you want. It's reliable because it will store copy of data, because in case if there is some hardware failure on one machine, still it can actually, it stores the data in some copy manner. We'll see how. So one of the things what Hadoop does is, like, it will store the data as copy on 3 machines. Supposing you have some file, then it will be divided among. Okay, suppose you have a file. Okay, you have a file, and how Hadoop is going to store is, now this is a huge file. It cannot be stored on one machine because it's a huge data. Now I have 3 machines, say. Then what my file will be divided into 3 parts, and this part will be stored on this machine, this part will be stored on this machine, this part will be stored on this machine. Like that, data will be divided and stored. Now supposing this fails, so will the data of this portion will be lost? No. Actually, Hadoop creates copies of the data. So whatever portion is here, it will also have replica here also. Means supposing A, B, and C. So this B portion, it will be storing on this node also. One copy it will be storing on this node also. One copy it will be storing on this node also. So in case this fails, the data can be recovered. It's not that the data will be lost. Okay? Got it? You can quickly type on the chat box. Okay, I'm having some questions here on the chat box. Which machine will do the master machine task? I didn't understand your question. Can you unmute yourself, and then tell me what is your question?
Hello.
Yes.
Hello.
Yes,
Ruchika, you
I
said
can hear
that
you. Mhm.
slave machine, if it goes wrong, master machine will take care of the remaining machines. No, I am asking you that is predefined, or we have to assign which machine has to take care of the remaining machines.
Yeah. That is actually we'll be discussing that one is the name node, other are data nodes. So data
Okay.
nodes will store the data, and the master node, which is the name node, will store the information, the metadata information, where the file is stored, on which node it's stored. So it will create replica
Okay.
accordingly. We need not create the replica.
Mhm.
That framework Hadoop
Okay.
will do that.
Mm.
Does that answer your question?
Yeah. Yeah.
Thanks, Vinay.
Thank you.
So Hadoop is scalable, it's very reliable, and it's flexible. You can decide to store a lot of data and decide to use it later also. And it's really economical because we are going to use only cheap commodity hardwares. Ordinary computers can be used for the processing. We need not have high-end machines. So quick quiz questions, or if you have to answer quickly on the chat box. What is distributed system? Is it one machine processing a file, multiple machines processing a file, a traditional system, or in-memory computation? Quickly on the chat box. I know everybody of you know the answer. Please be a little interactive and little be energetic and answer the questions quickly on the chat box. Only 4 people answered. There are 8 attendees, 3 more, I mean. 2 more. Yes, people answer. Come on. Very good. Thanks for answering. Oh, everybody got the right answer. That's great. Okay, so what is Hadoop? It's an in-memory tool used in Mahout algorithm computing. It's a computing framework used for resource management, and it's a framework that allows for distributed processing of large data sets across clusters of commodity computers using a simple programming model, or it's a search analytics tool which provides access to analyzed data. Yes, correct. So thanks for answering. Well done, guys. Okay, so now coming on to, now we learned, okay, what is big data, what is this Hadoop? So Hadoop is basically for storage and for processing. So the core Hadoop components is HDFS and MapReduce. So you see this big stack. Let's start from the bottom. So we have this HDFS. HDFS means it's a Hadoop distributed file system. So like you have file system, Windows, Unix. So here with Hadoop, because you're going to store data in a distributed fashion, you need to have a different type of file system, that is the distributed file system. And because it belongs to Hadoop, that's why it's called Hadoop distributed file system. So this is the storage functionality of Hadoop framework. Now, when the data is stored, okay, fine, the data is stored, now file is stored. I want to suppose perform some operation on it. Supposing I have a file, I want to do word count operation on it. Now my file will be divided into parts and stored on different nodes. And then now I want to do word count. I'll write a Java program maybe and say I want to perform some operation on this data. So that program will actually go to those nodes and process that file and calculate the word count. So we need to actually store, and then we need to process the data also. So storage part is done by HDFS of Hadoop, and processing is done by MapReduce component of Hadoop. So these two things, they belong to the core component of Hadoop, that is for storage and for processing. Jan will discuss later. Now you have stored the data, processing is also done. So this is the main functionality. But what happened with time, like people started facing problem. What problem? Like how to get the data from different sources. Like I'm a company, I have some data in my website logs, say log files are there. I want to gather the data to find out what my customers are thinking about me. And I have I want to also gather the data from tweets. And then I have some data in my relational databases, and all of them from different data sources. I want to gather the data and get into Hadoop world. So that is a challenge. So people started thinking how to ingest the data. So what happened? There were like different tools that started coming up. So this here you can see the Sqoop and Flume. So Sqoop is a tool that is used for data ingestion. Data ingestion means get the data. Now you have some data in relational databases, okay, in your company. Now you want to get the data to analyze, because that has become really huge and you can't analyze it there. So you want to get it to Hadoop framework, store it in HDFS, and then analyze it. So you need some ingestion tool. So that is, Sqoop is used to ingest data from relational database to HDFS. Then you have Flume. This is going to ingest the real-time data, the data that is getting generated in real time, like tweets, log files. So this is a different tool. So there are many data ingestion tools, but in this course we'll be discussing about two major tools that are very important for certification purpose also. Sqoop and Flume will be discussing. Then we have this another tools that are coming up is like we have Pig and Hive, you see here. So, you know, the MapReduce programming, you need to know a little bit Java about it. So MapReduce programming is all done in Java. Okay, you'll have a mapper code, reducer code, that is all written in Java. So that makes it really complex. Earlier, people divided their problem into map tasks, reduce tasks, and then they wrote the Java code. But the companies like Facebook and Yahoo, like Hive was developed by Facebook. So Facebook saw that MapReduce programming is really going to be very complex and difficult because we don't know Java. People there, they knew more of SQL. So they said, okay, let's have one tool called Hive, which you can write SQL HiveQL queries easily, but it will be working on top of MapReduce. Underlying technology will be MapReduce, but it's easy to actually write the queries in SQL rather than writing a Java program. And it's much faster also. Then Yahoo Yahoo developed Pig because people there in Yahoo were more aware of scripting type of language. So Pig, they developed Pig and Pig Latin language, which is very much similar to English, and with statements, very simple language, Pig Latin they developed, and that is used to analyze the results. Hive and Pig are actually used by um, for data analysis. Okay, so the people who are aspiring to become data analysts, they need to be really proficient in Hive and Pig. Pig is mainly used by data scientists, like for data cleaning purpose and all that. Hive is used by data analysis to analyze the data that is stored in HDFS. Then comes the machine learning thing. Mahout is being replaced by now Spark machine learning. So this is going to be obsolete. Then you have Oozie, that's a workflow engine. Supposing you want to have multiple jobs. First you want to ingest the data, then you want to analyze it, maybe with Pig, then with Hive. So there is going to be a workflow, one after another. So we'll be discussing all these things in detail. This is just a overview of what we are going to do in the course, okay, what we are going to have. And then we have Hbase, which is a columnar data store. So this is a NoSQL database. In this big data world, no SQL, we can't work on SQL. We need to work on some other type of database that is called NoSQL, because here we are going to store the data in different nodes and we want to analyze it. We also want to scale out. So that relational databases, they do not work well with these type of problems. So we need to have a different set of database, that is the NoSQL database. So Hbase is one of the NoSQL databases. Okay. So these all the components of Hadoop, we are going to discuss one by one, do assignments on them, then do you know, are you going to do project on these Flume and Sqoop and Hive, all these, and also we are going to discuss about the certification thing. And after discussing these components, we'll be also covering Spark, because Spark is also, if you're interested in certification, then definitely you need to learn Spark also along with this. So after you learn the basic Hadoop and everything about the Hadoop stack, then we'll move to Spark. Okay. So this is what is the flow goes. We have data ingestion. We get the data from using Sqoop or Flume. Then we can analyze the data using Pig, Hive, or Impala. Then we do the data processing using Spark or MapReduce. This is the Hadoop core. And then we can do a data exploration, or we can have workflow system. Also, we have NoSQL database, okay, to get the data into HDFS. Any questions? So what is in for you? Let's see the big data roles. If you're already working, any of you already working in IT, or all of you are freshers? Okay. So you can be an ETL developer, you can be Hadoop architect. If you're already working, you'll understand these terms. Then these are the big data roles. Supposing you're already working as a database admin, you can become a Hadoop admin, and you need to learn all these things about big data stack, HDFS, all these things. Then you can be a Hadoop tester, you can be a Hadoop developer, architect. If you're already working in these roles, you can just add your skills with Hadoop technologies like MapReduce programming, Pig, Hive, Spark, Flume, Kafka, Storm, NoSQL database, all these things, and you can then have these big data roles in your company. So this is what I wanted to tell about. Yes, Praveen, any question? So for learning Spark, like you need to learn any of the languages like Python, Scala. Okay, and if you're going for a data scientist thing, then you need to learn R. Okay, so depends on what you are keen on learning. So journey through the course will be 70% will be hands-on. We're going to do a lot of hands-on, and there'll be 30% more, less of theory and more of hands-on we are going to focus on, and more of real-world projects, assignments, quiz questions. And for every component, I'll be giving you the commands cheat sheet. You'll get the commands document. You'll also get the recording of the class. And you also get to talk with some industry experts. You're going to have interview preparation. Also, there'll be certification preparation for Cloudera and Hortonworks. So this is, I wanted to show which we are going to work on this. This is Cloudera, and we are going to do hands-on on this. And certification is also from Cloudera. So Cloudera, you see, is you need. I'll share the documentation also once you enroll for the course, how to install and do all those things, and then how to work on it. So here you see that it's looking like a desktop only, so kind of a machine on a machine. Here you will have all the components to work with. You'll have a browser, you can have an IDE for working on Java or any other language. Then you also have the command line terminal. Okay, so herein you, like if you know Unix, you can see the simple Unix commands like ls. It will list the files that are present here in the local file system. So these simple commands will be going through and learning. And similarly, if I want to see the files that are present in HDFS, I will be using some command Hadoop FS ls. So this is going, we are going to see the files that are present in HDFS. So simple command line tool, we are going to have command line, these commands on this prompt, Cloudera prompt, and we'll be going through it. So here, this is a one node machine. Supposing you want to create a cluster. So you can also create a cluster online also. You can pay and do this. On this Cloudera, this is free. So you can practice on this easily. Or for this, you need to have minimum 6 GB RAM. Okay, if you have less than that, then you need to extend it. Or if you cannot extend it, then you need to have your Linux machine, and on that you need to install Hadoop and other components together. So the best part about Cloudera is that you need not install Hadoop and everything separately. But if you have some Linux machine, then you need to install HDFS, means Hadoop framework first, then you need to have the other components we talked about, Hbase, Oozie, all these things. Okay, so best part about Cloudera is it gives you all these things combined together in one place. You need not install Sqoop, you need not install Flume, Hive, all this separately. All you'll get here on this. Otherwise, if you do not have Cloudera, you can have your Linux machine. There you can download Hadoop, okay, and then you can work on it. Got it? Any questions? Yeah, that's all from my side. It's just that I wanted to say that this course is going to be really good for the career, and it's going to be lots of hands-on, and they'll get good real-world projects to work with us. And also, time to time, they can ask any questions, any queries, they'll be answered. And also, they will have good certification preparation with this course, and they'll be able to crack the Cloudera certification, which will definitely add to their resume.